Hello again. In this video, I'm going to review the homework questions, Chapter 19, Elasticity. Here we go. Hopefully what we're talking about started with a question like this. When the price of shirts emblazoned with a college logo is $20, consumers buy $150 per week. When the price declines to $19, consumers purchase $200 per week. The price went down, the quantity demanded went up. Based on this information, calculate the price elasticity of demand for logo emblazoned shirts. The author's talking about, shirts that you see that have something, I don't know what emblazoned, but I guess he means it could be embroidered or ironed on, I don't know. What I've done on my paper is to just consider this segment of the demand curve, basically, that he's given us, and we're asked basically to calculate this elasticity over this segment. So we have the following prices. Let's figure out how I want to put this. And following quantity demanded, two quantities. We have 20 with 150 demanded, and we have $19 where 200 will be demanded. So that's one segment of the demand curve. And when we do our calculations, we use the midpoint method or his average cost method or average, whatever he calls it. It's the same thing as the midpoint method. You'll see that now as I do it, I think. So my general form for elasticity, price elasticity of demand, is the percent change in the quantity demanded given some percent change in price. Okay. Percent change is new. New minus new, I'll get there, new minus old over old. This is an important concept for us. It helps you to understand the meaning of elasticity or price elasticity, but it's not exactly what we can use to do the midpoint method, to do the calculations. Let's set this up and make the little tweak right now. So we're going to calculate price elasticity using the midpoint method. So we're going to have the quantity aspect on the top here. It's going to be a large, ugly, complex fraction. And the quantity portion will be everything up here. We're going to have the price aspects down here in this large, complex fraction on the bottom. So the truth is still going to be here, new minus old over old. And we were talking about a price decline. So the quantity demanded, new, is 200. Minus old, 150. Instead of old, we're going to use the midpoint of 200 and 150, which I'll write out this time, but I think I probably don't have to right now. You probably see it without me writing out, but I don't know. I'm looking at my computer. Who knows? So to find the middle of 200 and 150, I could do 200 plus 150 divided by 2. That'll be 175. Perhaps you saw that. That's why it's the midpoint method. Most people just see it and use the midpoint. Your author, I actually feel like this overly complicates things. And I also wrote it pretty small, didn't I? Your author prefers to call it the average denominator or something like that. The average of two numbers, just two numbers, will be the middle of those two numbers. So it's the same thing. The price facet to our complex fraction is still going to be new minus old. The new price is 19. The old was 20 over the middle of 19 and 20, which we could just say it would be 19 plus 20 divided by 2. That's 39 divided by 2. And 39 divided by 2 would be 19.5. So this time, here I wrote out what I'm doing in my head. Here I just did it in my head. Most of us would just look at 19 and 20 and say, the middle of 19 and 20 is 19.5. So there are different ways to do the same thing. Now I'll simplify this a bit. Let's see. I'm going to fill in these blanks. 200 minus 150, I'm getting 50. 200 plus 150 is 350 divided by 2 is 175. You already knew that because you were thinking halfway between 150 and 200 is 175. 19 minus 20 is, that's pretty easy, minus 1 over 19.5. And, yeah, I'm just checking my work, make sure I haven't made a boo-boo. Now, to handle a complex fraction like this, you might remember that you flip and multiply. You could have at any stage entered any of this into a scientific calculator and just come right out with an answer, but you know, I'm doing it step by step. So let me work down here just in the interest of space. This, I'm going to flip like that and multiply against this. So I'm going to fill in this blank, but I'm going to write it down here. So 50 over 175 times 19.5 over negative 1. I flipped and multiplied. Now I go across here, and the bottom I can see in my head, negative 175. The top, I'm going to fudge it a little bit. I'm going to look at my notes. That's 975. And now I have no choice but to do a little bit of actual division, which I did do on a calculator, I think, and that becomes negative 5.57. And we don't care about the sign, or we're only interested in the absolute value. So therefore, elasticity is equal to 5.57. Do we say this is elastic or inelastic? Yes, it is elastic. So we would say that these consumers were very responsive to this price change. Probably this would be something that would be a luxury, or there were many close substitutes. And this thing coming down 5% on sale, 5% off, really drew people in, the consumers. So that's 19.1 or 19-1. I hope you enjoyed it as much as I did. Let's look at 19.2. By the way, welcome to my office area. That's my desk, our back patio, my wife's desk. Today I might have her a little bit on the neatness, but usually that isn't the case. I cleaned it up for you. 19 to, oh, did I say 2? We're on to number 4 next. $19.4 goes something like this. In a local market, the monthly price of internet access services decreases from $20 per account to $10 per account, and the total quantity of monthly accounts across all internet access providers increases from 100,000 to 200,000. What's the price elasticity demand? Is demand elastic, unelastic, or inelastic? This one is I'll give you I'll get spoiler alert. The price is falling in half. If you look at these numbers, he's using simple numbers. The price is falling in half, going down from 20 to 10, right? So it's half price. The quantity goes from 100,000 to 200,000. The price fell in half, but the quantity doubled. You might have a sense of where that's going to land us at the end of the day. That's all I'm going to say about that. Let's go ahead and do the calculation. I erased the formula. I wish I hadn't done that. Okay. Okay. The price has gone from $20 to $10. So I'm going to try to skip the step where I just write out the segment of the price and quantity. It is in the question, so I'm just going to fill it right in. Let me go ahead and just rewrite that formula. Price elasticity. Price elasticity using the midpoint method is what we're going to be doing. And I'm going to say it like this, because I'm going to write the general formula, then I'm going to fill it in. I'm going to write the general formula here, as I've been doing, but I did say midpoint method here. So under new, I changed my mind. That's not mathematically correct to do what I'm doing. Let me go ahead and let me not do that. Let me just say, here's the general formula. Price elasticity of demand is equal to percent change in quantity demanded over the percent change in price. Okay. Now, we're going to use the midpoint method. So I'm going to fill these in, and I'm not going to just use percent change. I'm going to use in the denominators of each, instead of the old price or the old price and the old quantity, I'm going to use the middle of the two. So I'll start on the bottom because that's the first part of the question. The price fell from $20 to $10. So my new price is 10. My old was 20. What's the middle of 10 and 20? Yes, 15. On the quantity side, the quantity rose, let me double check my stuff here, from 100,000 to 200,000. So my new one is 200,000, and I will write it out. New minus old. Instead of being over old, it's going to be the middle of those two figures. What's the middle of 100,000 and 200,000? Well, we could, if we had to, we could calculate it. It's the average. So we have two observations here. 200,000, 100,000, that's two numbers. They sum to 300,000. The sum of the observations divided by the number of observations. 300,000 divided by 2, you already saw it, 150,000. So there's my setup. And then this is going to equal, I'm seeing 100,000 up here over, whoops, I forgot a zero in there, didn't I? Whoopsie. I wrote 15,000, you knew that. 150,000 down here. And then down here, I have 10 minus 20. I'm seeing that as negative 10 over 15. Well, these are big numbers, and when I'm looking at big numbers like this, I'm thinking to myself, what do those equate to? How can I make this something more simplified? Isn't it also true that 100,000 to 150,000 is 2/3? I mean, I know I'm fairly practiced at math, so maybe that's clear to me, but when I see 100 over 150, it's pretty clear to me that that's 2/3. And look at this at the bottom. 10 over 15. It's the same thing. So I could see it here. I've got something divided by itself. Or I could flip and multiply. If you're into that, this is equal to, if I flip and multiply, like I did before, 2/3 times 3/2. And you get 6/6. And now, I hope it's clear, you're talking about 1. Someplace along here probably got clear in your mind, hey, it's the same thing divided by itself, so I got 1. So what's the elasticity here? Unit elastic. Again, go back to the beginning, when I said it was a spoiler. The price fell in half, the quantity demanded doubled. It's a proportionate shift in terms of total revenue, something we looked at with the chapter. This firm can cut their price in half and double the quantity that they sell. Or if they doubled their price, the quantity they would sell would fall in half. being inelastic means their total revenue is what it is with respect to price. They can change it, but it's going to have an offsetting effect on the quantity demanded. It's just going to balance out. So I sort of think of it like a seesaw. So that's number 4. What do we have to do next? Number 5. Before I read it, let me clear my board. You can see who Hermann. You can research who Hermann Hesse is while you're clearing my board. Was. Keep erasing more than I want to. Did you find out? Hermann Hesse is my favorite author. He was a German author in the early 1900s. Wrote Siddhartha, famous book, and some others. And I went to his birthplace in Kalv, Germany. There's a museum there for him, and got that nice poster. And that is an Andy Warhol on that side. He was kind of a hippie kind of guy in the 70s, and he did pictures like that. You might have seen him with Marilyn Monroe. He did that with Hesse as well. So there you go. There's your time filler while I got my board erased and the answer to the questions you were dying to know. Here we go. Number 5. At the price of $57.50 to play 18 holes on a local golf course. You know, how about we say a game of golf? Okay, throwing an extra number in there doesn't help you, right? I guess he's trying to be funny. Anyway, it's $57.50 to play a game of golf. 1,200 consumers pay to play a game of golf each day. A rise in the price to $62.50 causes the number of consumers to decline to 800. What is the price elasticity of demand? Is demand inelastic? Blah, blah, blah. Okay. So these numbers aren't as plain as the last one. So I'll go ahead and set up a little demand schedule just to get those numbers recorded so I can draw from them to fill in our formula, all right? We're given 2 prices and 2 quantity demanded. Observations, $57.50 and 1,200 games are purchased. The price rises to $62.50 and only 800 games are purchased. So there's a segment of the demand curve or segment of a demand schedule for us. Our general formula, price elasticity of demand, is again, this is probably going to be burned in memory, I'm guessing. It's percent change in the quantity demanded given some percent change in price, except we're going to tweak this for our midpoint method. So elasticity using the midpoint method, price elasticity, will be equal to, I'm just going to set up my complex fraction. I just find it easier that way just to know I'm always talking about my new minus old over the midpoint on the top and my new minus old over the midpoint on the bottom. I don't know, do it however you like, but the structure helps me. Let's see, this time we're talking about a price increase, so we're going this way. So my new quantity is 800 minus my old is 1,200. And the middle of 800 and 1,200, that's pretty easy. That's 200 each way from 1,000, right? Did I get that? Check my notes. I don't want to mess up. If it's not clear, I'm shooting these videos in one take. I messed up on my answers here. I'm going to work it here because I think it's right. Yeah, I have a mistake in my old answer. Fine. Okay then. The new quantity was 800. The old was 1,200. The middle of 800 and 1,200. That's 2,000 divided by 2. So I know I'm right there. I got it. I did something. I must have been working. I don't know what I was doing when I wrote that there. But anyway, my new price is $62.50 my old price was $57.50. And the middle of these is not super clear. Perhaps perhaps it isn't, but this is $2.50 away from 60, and so is this. Or you could add them together, 62.50 plus 57.50. If you add them together, you're going to get to 120. And 120 divided by 2 is 60. So that's the midpoint. All I'm doing is looking at these and finding the middle of them. If you wanted to, you could add those together and divide by 2. That's the average of the two, and you'd arrive at 60. Whichever way you prefer. I based on my experience in class, I'm pretty sure people are just looking at them and finding the midpoint. Now we can start simplifying. That's a negative 400 on the top over 1,000. And that difference, I'm getting 5. That's what I got in the past. Over 60. Now I flip and multiply. And so this is equal to, let me make sure you can see that, negative 400 over 1,000 times 60 over 5, right? And I'm seeing 5,000 down here and negative 2,400 up there. Or 2,400. 2,400, I don't know where I'm getting an extra zero. No, I was right. 3 zeros. 24,000, I was right the first time, that's where I'm getting it. 24,000 at the top, 5,000 in the bottom. I can see that goes in there 4 4/5 times. So this is equal to, and it is technically negative 4.8. And do we care about the sign? No. We only care about the absolute value with price elasticity. So is this elastic or inelastic or unit elastic? And its difference from 0, or I'm sorry, it's difference from 1, it's greater than 1. So this is what we call elastic. This is a responsive crowd. Think about it, games of golf. Is playing golf a luxury or a necessity? Yeah. It's a luxury, so we shouldn't be surprised to find an elastic demand curve, and that's probably why he chose golf. Although I don't know why he had to call it 18 holes and not just a game of golf. So then the next one we did, we don't have any calculations for. It is very difficult to find goods with perfectly elastic or perfectly inelastic demand. We can, however, find goods that lie near these extremes. Characterize demands for the following goods as being near perfectly elastic or near perfectly inelastic. So we can do this thinking of our determinants that we listed, of which I typically list 4. Our book actually lists 5. Because I usually don't worry about the percent of budget. So here we go. Corn grown and harvested by a small farmer in Iowa. The demand for corn from a small farmer in Iowa. Well, are there a lot of small farmers in Iowa? And then in Nebraska and Colorado, even over here in Maryland? Yes, there are. And they're small, so they can't influence the price. And corn, there may be different kinds of corn, but within a category of corn, is there any difference in these products from one small farmer to the next? No. So what you have is many close substitutes. So are we talking about an elastic demand curve or an inelastic demand curve? Yes, an elastic demand curve. Later in the semester, we'll start to draw that as perfectly elastic, that very example. How about B? Heroin for a drug addict. What do you think? What is true about heroin for a drug addict? You're talking about someone who's addicted to something there. If the price rises, will he or she stop buying it? Not so much. They'll find a way to pay that price. And so you're talking about a vertical demand curve. You're talking about something that to the consumer in that market is a necessity or feels like a necessity to the person in that market. So you're talking about an inelastic demand curve. Now this question, C, I think he, I don't know, I think he like chickened out. Maybe it should be water for someone stranded in the desert. Water for a desert hiker is kind of a poor example because if you're a desert hiker, you probably left into the desert prepared. So you probably not only, aren't buying water, you have your fancy, what do they call those things? The water bottles that go on your back. My son has some for camping. I can't think of them. Things with the hoses. I mean, you would leave into the desert prepared to be, to have your water. He's trying to, I don't know, make this clever and suggest that if you were in the desert and were interested in buying water or there was a market for water available to you, you would be willing to pay quite a bit for water just to have the amount of water that you would need to make it through the desert. So he's trying to say that this is a necessity and an inelastic demand curve. It's just not the best example to say water for a desert hiker, because a desert hiker is there by choice. That doesn't really, to me, signal necessity. But he did mean for it to be necessity. Hope I'm making sense. Anyway, letter D. How about one of several optional textbooks in a pass-fail course? Let's face it, very few people are even going to buy this at all. Certainly if the price goes up, they're out. They're not going to buy it. This is an elastic demand curve with all these different signals in the prompt here. He's talking about something that is a luxury. Then I think we did number 8. Suppose that over a range of prices, the price elasticity of demand varies from 15 to 2.5. Over another range of prices, the price elasticity of demand varies from 1.5 to 0.75. What can we say about total revenues and the total revenue curve over these two ranges of the demand curve as price falls? Well, as price falls along that first segment from 15 to 2.5, 15 to 2.5, they're all well above 1. So you're talking about an elastic part of the demand curve. So as the price goes up, what's going to happen to your consumers? If you're the seller, lowering your price goes, I'm sorry, I think I just misspoke. What can you say about total revenue? If the price falls, you're the seller, you're lowering the price over the segment of the demand curve where the elasticity is 15 to down to 2.5. You're talking about an elastic portion. So you're lowering your price and you have a flood of consumers coming in because it's an elastic portion of the demand curve. So your total revenue will go up by lowering prices along that segment of your demand curve. From 1.5 down to 0.75, that includes 1 and below. So this is a less price elastic portion of the demand curve, ranging into inelastic. So lowering your price there will shift from increasing your total revenue to being constant to decreasing your total revenue along that segment of the demand curve. Or you could say the first portion is in the total revenue curve, which I haven't discussed in my video. It is in the book. I don't think we're going to use that in this chapter. We might look at it again later, but it's just, you can see it in the book. It's just not that important. But if you want to look at it, it's just a curve, a parabola, and the areas where total revenue is rising are where the demand curve is elastic. It's flat, zero slope, where demand is unit elastic, and then it begins to fall in inelastic. So it's saying the same thing, just in a curve instead of words. So I hope that's clear. Number 9. Based solely on the information provided below, characterize the demands for the following goods as being more elastic or more inelastic. So this is going to be referring back to those determinants of price elasticity of demand. And the first one is the one that I don't worry about very much. A 45-cent box of salt that you buy once a year. If you go into the store and that 45-cent box of salt is 60 cents, I mean, that's a lot. That's a quarter. That's 25% higher than you might have expected. Do you go to another store to buy it? No. you buy it anyway. So if you buy it anyway, no matter what happens with the price going up, that means it's inelastic. It's because it's a small percentage of your budget. How about B? A type of high-powered ski boat that you can rent from any one of a number of rental agencies. Elastic. Talking about something you don't need it, and it's got many close substitutes. It's very easy to not buy that if the price is too high for you. You look at it and go, oh no, that's too much. It's going up. I'm not interested. It's very easy to walk away from. C, a specific brand of bottled water. A specific brand of bottled water. Most of the bottled water I see on people's desks in class are completely interchangeable. So if the price of one of them goes up, why wouldn't you just go buy the next one in the case? I mean, you would, right? That has many close substitutes. So that's elastic. I'll use this to point out the definition of market. A specific brand of bottled water has an elastic demand curve, but water has an inelastic demand curve because it's a necessity. So the definition of market really matters, but he's defining the market very narrowly, so it's an elastic demand curve, elastic with an E. Automobile insurance in a state that requires autos to be insured, but only has a few insurance companies. Well, if it's required, it sounds like necessity to me, and having a few companies further says there aren't many substitutes. So you're talking about an inelastic demand curve. The consumer there is kind of stuck. If the price goes up, they're not going to change their behavior very much because by law they can't, or they have to stop driving or break the law. Letter E, a 75-cent guitar pick for the lead guitarist of a major rock band. That would be an elastic demand curve because of percentage of income, and that's adequate because of percentage of income. It's 75 cents to a rock star kind of person who's making presumably a lot of money. So they'll go ahead and just say, fine, whatever. I'll pay it. I hope I answered all those adequately. So the next one we did, I think, was number 12. A 5% increase in the price of digital apps reduces the amount of tablets demanded by 3%. What is the cross price elasticity of demand? Are tablet devices and digital apps complements or substitutes? So we can think this through, and we kind of know the answer. I mean, think about it. Digital apps and tablets, they go together. Like we hopefully we know they're complements before we've looked at this to answer the question. Doing the question should confirm, knowing what we know should be a check for what we're doing with our calculation. So cross-price elasticity. With cross-price elasticity, the elasticity between goods X and Y is equal to the percent change in the quantity demanded of, let's say, good X, given some percent change in the price of Y. Like, how does it react? How does the other thing react to the price change of this thing? So, 5% increase in the price of digital apps. This is a 5. And it's an increase, so it's a positive number. That's probably the tricky part of this. Maybe it's, you just have to remember to think of the sign in the first place if you do it outright, when you do it outright. 5% increase in the price of digital apps. So that's the price component right there. Apps are the Y here. The X is the X is the tablet devices, and they decrease, so reduces, it says. So that's a minus 3. So it's minus 3/5 or negative 0.6. Here are point of reference isn't really about one, it is actually about the sign. We don't just ignore the sign. The sign tells us the relationship between these goods. All it's saying is the increase in the price of this decreased the quantity demanded of that. Really, I'm reluctant to use quantity demand. It shifts down demand because it's a rise of the price of substitute. So, I'm sorry, rise of the price of complement. When the complement's price has gone up, the consumption of this has gone down. The negative sign, I mean, the calculation is almost irrelevant. Having a negative sign tells me that these are complements. The price of one thing has gone up and decreased the demand for the other thing. So the negative sign tells me they're complements. And that's what we were asked in number 12. And I think that's it. Yeah. Great. Well, let me know if you have any questions.